I'm Anil Kumar, sharing with you concept of one-side limits and piecewise functions in this particular video. The question here is, determine any value of x at which f of x is discontinuous. We are given the function f of x with 4 pieces. It is equal to 1 minus absolute value of x when absolute value of x is less than or equal to 1. It is absolute value of x minus 1 if absolute value of x is greater than 1, less than or equal to 2. It is equal to x minus 3 whole square for x greater than 2 and x plus 3 whole square for x less than minus 2. So we'll first understand how to sketch such a function. So what I'll do here is we'll kind of make a graph. Okay, so just thinking. So we'll make a graph here. Okay, let's say that is your x and y axis. We'll also consider a number line, just because there are different intervals which we are talking about. We'll consider a number line also. This is a 0 for us. Okay. Now, if you look at the function, first piece is when absolute value is less than equal to plus 1. That means it is within this interval. Is it okay? It is within this interval. Less than equal to 1, right? So let's say this is 0, this is minus 1, this is minus plus 1. So in this interval, the value of the function is 1 minus absolute value of x. How to sketch it? We can take values. If I take 0 here, it is 1. So let's say, so this is 1 for us. So first point. If I take these two values, if I write 1 here, absolute value is always positive. So 1 minus 1 is 0. For minus 1 also, it is going to be 0. So the graph which we get will be kind of like this. Is okay? Where this point is 1. Perfect. And this is minus 1 and 1. Now let's get back to the other interval. When absolute value is between greater than 1 and less than or equal to 2. So absolute value, right? So that really means that even if it is minus x, first let's simple is from 1 to 2 is very simple to consider, right? So 1 to 2 is very simple. So we're talking about now this portion. This portion is here, correct? 1 to 2. If I write x as minus 1, right, then that becomes one limit. Is that okay? Minus 1 is plus 1. Minus 2 is also within our limit of 2, correct? So we are also talking about this limit here. Is it okay? So now we are talking about the interval from 1 to plus 2 or from minus 2 to 1. It does make sense to you, right? So this is what we're talking about. So in both ways, however, the value which is included for us is not at 1, right? So if I write 1 here, then 1 is not included. If I write minus 1, right, so that is not included. But the others are. Is it okay? And the value of the function is absolute value minus 1. So if I write here 1, 1 minus 1 is 0, so it's the same point, correct? Minus 1 also will give me the same point, but I'm writing a whole. It overlaps the previous one. That's the whole idea, correct? And if I write 2 here, 2 is 1, so we get a point here, which is included, correct? So we get a graph which is kind of like this. Does it make sense to you? Minus 2 and 2. Now let's look into the next part, which is when x is greater than 2. That means when we are working on this interval, then it's a square function x minus 3 whole square, right? Which is a parabola, shift 3 units to the right. So 3 units to the right will be 1, 2, let's say this is 3 for us. So it's definitely a parabola which kind of goes like this, right? So we could draw this parabola as kind of like this. Does it make sense to you? For x greater than 2. So this one is a hole, but it's already filled in by the previous one. Perfect. On the other side, let's take this color now, green. Less than -2 is a parabola which has been moved 3 units to the left. And so, if you sketch it, it will be kind of like this. This one is a hole, but it's already filled in. So that's how you can sketch this function. We'll call this f of x. This is x for us. Let's get back to the question. It said, determine any value of x at which f of x is discontinuous. Well, from the function sketch, we can say it is continuous. So there is none, no value, right? So the function is continuous in its entire domain. Perfect. Now that's one way of doing it. The other way to do it is that these are the points, right? So you could find limit of this function as x approaches 1 from left side, or when x approaches 1 from right side, or when x approaches 2 from left side, or when x approaches 2 from the right side. So once you do all that, then also you can do, this is with the positive side, same things you have to do for x approaches -1 from the left side, -1 from the right side, x approaches -2 from left side, and -2 from the right side. So that way you could do it from the one-sided limits, but in such questions, sketching is a better way of doing it, right? So that's why I went into details of sketching such a piecewise function. You could clearly see that all the pieces are joined together on their boundaries, and therefore the function is continuous. I'm Anil Kumar, and I hope that helps. You can always share and subscribe to my videos, and if you like, please like. Thank you, and all the best.